Howdy everybody, this is Pragati Arumugamudayakumar and I'll get started with Milestone 5 for the course Advanced Data Management. Today's table of discussions will be as follows, and I'll initiate by discussing what is data lakes and warehouses. So the basic philosophy of what data lake is, you will store everything now and then define structure later. So similar to how in a lake the water flows, here the data flows. So the data is fetched from various resources, various data sources, and the data structure might be either structured or semi-structured or unstructured. It can be anything. And for now in the data, like you're just storing everything as it is, and then you are defining the structure later in the forthcoming process. And the basic philosophy of data warehouse is store only what's cleaned, aggregated, and useful for business queries. So similar to how warehouse is organized, where everything is basically encapsulated in a box, and then it is stored in a rack manner. Over here, the data is stored in a way, cleaned and aggregated way, and in a specific table with the predefined structure. So this is how data warehouse works. And now let's see the main difference of lakes and warehouses. So in data lake, the data type can be either structured, semi-structured, or unstructured. But in data warehouse, it has to be structured because we can only store cleaned and formatted data in data warehouse. But data lake can store everything and it will retain whatever the raw structure of the data is. And if you see the schema, data lake is based on schema on read. So schema on read is basically once after reading the data only, you will create a schema for that data. So the data can be in whichever structure it might be, and then the schema is being created dynamically during the write of the data into the data lake, and thus it is flexible. The schema is flexible here, but in data warehouse, it follows schema on write, which basically means we have predefined schema. For example, if you take an Atham at MariaDB case, we had products table, customers table, and each had columns defined and column types defined into it. So this has predefined schema, and the incoming data is compelled to store in this predefined schema. And if it is not complying with the schema, then it will throw an error. So this is very strict compared to data lake. And access pattern, we can access the data lake data to have some data exploration and utilize it in machine learning principles and perform ELT operations. And data warehouse data can be utilized for implementing some business analytics dashboards and SQL analytics. And in terms of cost, data lake implementation is very low because you're just reading the data and storing it as it is. But in data warehouse, you are reading data and doing some processing, formatting the data, and then you're storing it. So in data lake, it's just storing cost, but in data warehouse, it's storing cost plus computational cost. So data warehouse are higher. And this is the integration of data lakes and warehouse into our existing MariaDB in Ethermat's case or in case of any existing databases. So if you take data lake implementation, first the data lake should be stored in any storage architecture. And one such example is AWS S3. So data lake is basically stored first and then it is being cataloged. The cataloging means the data should be labeled or it should have some logical segregation among it so that the data will be easily utilized for the further pipeline. And one such platform to facilitate this is AWS Glue. And then the third phase is queryable. Queryable as in from the data lake, we should be able to retrieve the data and then pass on the data to the forthcoming pipeline architecture. So in case of MariaDB, it might be staging table. In case of NoSQL, it might be some databases. So queryable can be achieved using Athena or Spark. These are basically data streaming platforms. And then in case of data warehouse implementation, again, cataloging and queryable is going to be similar, but then instead of storing in AWS S3, we can store it in AWS Redshift because data warehouse data is very structured and Redshift is more appropriate than S3. So data lake use cases, according to the Ethermart use case, these are the possibility where data lakes can be implemented. For example, when we are requested to track the web and app click streams of all the user, the data structure here is in JSON format. So here we cannot store it in a traditional RDBMS structure, and thus we can initially store this into a data lake, and then we can pass it through any NoSQL databases. Similarly, Ethermart also sells IoT products. So IoT smart devices will provide time series data, and this series data can be stored in data lakes. Similarly, social media feeds and customer support chat logs and marketing campaign data and product image metadata. So in all these four cases, we are utilizing unstructured data, and this unstructured data will also be stored in data lakes because this doesn't comply any of the ACID properties, and further it will be stored in NoSQL DB. So the use cases for data house might be data warehouse will be very structured and rigid. Basically, the use case which will utilize the data that is already formatted. So in Ethermat's context, we can see cross channel sales analytics. So this is one use case where, since data is coming from different platforms, we can perform a cross channel sales analytics where we can analyze which platform is producing more results, or which platform has high traffic, or whatever it may be. So this is one use case. And customer lifetime value analysis, since customer also utilizes multiple platforms, in store, websites, applications, and etc., we can actually analyze customer lifetime based on different whatever platforms they are using and whatever purchases that they are making. And similarly, product performance and review correlation, inventory forecasting, real time executing reporting, these are example use cases which can be utilize data warehouse and implemented, because all these use structured data which is queried from our existing NoSQL or MariaDB infrastructure, and we have to perform some analytics based on this. So next I'll move on to discuss the hybrid Ethermud data architecture. So as you can see, I have segregated my user inputs into two different categories. One is transactional input and one is operational input. So the user is same, but the user may produce different kinds of input. Transactional is products, orders, or customer, which is structured, and operational is IoT click streams, IoTs or click streams, and reviews and logs. These are unstructured. So for transactional input, I want to pass in the data into MariaDB, which follows as a structured layer. So first, I will pass in the transactional inputs into a staging table, and from the staging table, I'm going to pass it into MariaDB, which follows an SQL table. So this is structured, and similarly, if you come to operational inputs, this is unstructured, and since I'm passing it to data lake first, and from the data lake, I'm going to pass it to NoSQL database. And now both MariaDB and NoSQL can go through ETL or ELT pipeline based upon whatever processing, whatever transformation that the data needs to be done, and based on the use case, it will go through the ETL and ELT pipeline, and then this ETL and ELT pipeline will store the transformed or much more formatted data into data warehouse. So basically, the user data initially originates as a pool and then stored as a formatted and cleaned manner in data warehouse, which can further be utilized for analytics and dashboards and everything. So now NoSQL integration in my POC. So I have implemented so basically, since this is a multi-platform architecture, the customer will use any application, and the customer interaction with each application might be different. So I'm going to track the click stream of all the customer based on their platform which they are using, and then based on the operation that they are doing, and then I'm going to perform I perform analytics, how long the user is staying in the application, what are all they are doing, which buttons are they clicking, and everything. This is what clickstream tracking is. And in order to perform this, I have utilized MongoDB, and I have implemented CRUD applications of this clickstream operation. And I'll further get to my demonstration. So this is how I'm going to implement my NoSQL MongoDB implementation. In order to perform this, I first need to install MongoDB into my AWS EC2 instance. In order to do that, I want to execute these commands, which I have already done. But what these commands does is, MongoDB, we have to access MongoDB, right? So we want some authorization token. So with that authorization token only, our EC2 instance can connect to the MongoDB and talk with it. So these lines of command will help us to fetch the EC2 instance and store it in, fetch the authorization token and store it inside our EC2 instance. And once that is done, this command will install MongoDB, and then I'm going to I'm going to enable my MongoDB and start my MongoDB. And if this I have already done, and since it is done, if I execute this command, I will able to see my status, which is active and running. My MongoDB is active and running now. And then if I proceed further, I have to change this configuration into my MongoDB conf file in order to enable my port, this is the 27017 is the MongoDB port, and binding address is 127001, which is MariaDB's binding address, and I'm enabling the authorization as well. Similarly, in the security group, I have to add an inbound rule, which is a custom TCP 27017 inbound rule for this is my public address, for this public address as source. So this is one step in security rule that I did. And then if I do this, my MongoDB will be initiated, and I have to create a user in my MongoDB to perform all the operation. In my case, the CRUD operation with admin access. So by this code, I'm creating a user which I've already done, and once that is done, I can actually access my MongoDB terminal using this command. So I'll run, which I have already created the user. So I'll directly run this command. So if I directly run this command, you will be able to see it is getting connected to the MongoDB terminal as an Ethermart admin, and this is the password for that. And you can see, yes, I have been connected, and my MongoDB terminal has been opened. So now I will go back to my original Ubuntu terminal and okay. So now I'll get to the code of where I'm performing CRUD operations. So over here, as you can see, I'm utilizing a Python code to perform this CRUD operation. And during the start of the Python code, I'm importing PyMongo, which is the library that will help me with all this MongoDB operations. And this is where I'm going to store my MongoDB URL, which I initially executed to connect to my MongoDB terminal. So over here, I'm connecting to the MongoDB terminal, and here I'm creating a database and dropping it if it already exists. I'm creating a database called Aether and dropping it if it already exists. And once that is done, I'm creating a collection, a client called Aether, and a collection called clickstream events. Since this is a document based storage, here we are going to create collections, not rows and tables. So yeah, clickstream events is my collections where I will store all my JSON data. And I have generated 10 sample data here. So as you can see, these are my JSON sample data, which will capture the essence of click streams. Here I'm actually hard coding the sample data, but in real case, these sample data will be fetched from any of the endpoints from the front end application. So yeah, these are my 10 sample data. And if I move through, this is my CRUD operation. Okay, so here I'm going to create documents, which is basically going to insert my data. So this is my collection object, which I initially created above, which I showed above. And I'm going to call the inbuilt function, which is insert many, which will insert all my sample events, which I showed before. So I have an array of sample events, which has all the JSON data. And this insert many will store all those into my MongoDB database. And similarly, there's another function called insert one, which will just store one document, and that is insert operation, and this is read operation where I'm going to have a for loop for doc in collection.find, which means collection.find is going to retrieve all the data in my collections, and I'm going to sort it using timestamp, and I'm going to iterate through the collections and going to display each collections as documents here. And here, since the limit is passed as parameter 5, only the top 5 first 5 retrieved elements will be printed in my case. And then update document. Over here, I'm going to get the event ID. Event ID is nothing but an attribute, a key in my document, in my JSON. And the new type is basically the value that should be replaced. So for this event ID, so I'm going to call the update one function, which is inbuilt function, and for my collection, and I'm going to check the event ID. If it is same, then I'm going to update the value of the event type to new type. So this is my update document, and delete document is again I'm going to use my collections object, and delete one is an inbuilt function, and I'm going to pass the event ID, so that will check for the corresponding event ID, and it will delete the document. And aggregate views is nothing but I wanted to perform one more step, which is analytics apart from the CRUD. So I am retrieving all the event of type view, and I'm going to add the event type view based on its product ID. So if there is a 5 event type view and the product ID of everything is unique, then I will display every product ID which has the highest, like I'll be ordering the event types and based on product ID's occurrence, and I'm limiting to 5, which is basically going to retrieve me the top 5 viewed items. That is the concept here. And yeah, this is the code that will call all my before created functions. So now I will go ahead and I will execute this code. So yeah. So in order to execute, I first have to go inside my virtual environment. And then as you can see, I already have my Python code created here. So the one that I showed you before. So I'll just go ahead and run my Python code, and you guys will see the output of it. So yeah, this is my Python code, and this is the output printed. So yeah, these are the warnings. We can ignore that. And over here, you can see it is connected successfully to my MongoDB and inserted in document. And then over here, I'm retrieving the data corresponding to, I mean, the first five as we saw in the code. I'm retrieving it, and then I'm performing an update operation where I'm updating event ID 004. And yeah, so I'm updating it, and then again reading once update is done, and I'm deleting the event which is 002, and then performing an aggregation where I'm retrieving the products which has a lot of views. In my case, every product has only single view, and that's why views is one, and these five products are printed here. So this is my NoSQL integration, and then I'll continue with my PPT. So security and hybrid data platform. So since data is coming from various platforms, there is high risk and high compliance that should be followed in terms of security in order to retain the data's integrity. So I'll first discuss the implications of hybrid data platforms. So storing data in multiple platforms, which is like in our case, we are storing it in SQL and NoSQL, right? So this will increase the attack surface, which is it is more prone to attacking since the data is very disoriented, it is segregated from one another. We have a lot of spaces where we have to secure, and this is more prone to attack. And the second implication is diverse platforms often have differing authentication. So since the data is coming from various platforms, each platform will have different authentication and access types, and this will every time we cannot ensure appropriate authentication and access in every platforms. So this might cause potential error or potential attack or malpractices. And the third implication is data flows and integrations. This might introduce multiple vulnerabilities in our ETL and ELT pipelines, and it might cause any exposure at the transformation stages. And the last implication is personally identifiable information (PII), and this must be protected at every step and system boundary to comply with regulations. And the best practices that we can follow in hybrid data platform is we can actually enforce the principle of least privilege, which is like in case of using AWS platforms, we can define IAM rules. So there are bucket level policies, bucket level rules, as well as IAM rules. So instead of just performing bucket level rules that will that will implement rules for a specific bucket or specific database, we can also provide IAM rules, which is enforce rules for the specific user. So we can cut down to the least privilege so that it is very rigorous, and role-based access controls are implemented for everybody in the system. And the second thing we can do is we can encrypt data which is both at rest and in transit. So even if it is stored in just database or while transferring data from one system to another system or across platforms, we can encrypt the data so that even if the data is being hacked, they will not be able to decrypt and utilize the data. And then the third thing is we can perform masking or tokenization. This will ensure PII fields wherever possible and segment the PII from less sensitive data. And the fourth thing is monitor data access with centralized logging and anomaly detection. And we can also we can regularly perform audit integration in our ETL pipelines. And we can also maintain compliance by mapping, documenting, reviewing all data flows, especially for PII from collection to analytics. So AI disclosure. For this, I have specifically used ChatGPT, Gemini, and also I used Perplexity. So I primarily leveraged these AI tools to research about data lakes, data warehouses, and security implications. And I also used this AI to perform get NoSQL script in order to perform the MongoDB implementation. And I also used AI to assist me with generating hybrid system architecture data. So I faced a lot of issues while generating data because ChatGPT and Gemini basically primarily being a large language model which is primarily based on text, the image generated was not very clear and accurate to whatever I required. So in this case, Perplexity came for my rescue and it actually provided me better results. So this is just a tip for whoever watching this. And limitations are AI outputs depend heavily on user prompt. So basically, I have to explain very clearly. Basically, I have to do a prompt engineering to get accurate result, accurate code, which will be ready to run without any error. So AI outputs are heavily dependent on whatever the user is saying. Even if one detail is missing, then the whole generated content might be not usable. And the reflection is the best result that we'll get out of utilizing AI is when we have a strong foundation of the underlying concept and we use AI to leverage the concepts that we already know and to build something upon that. We will, when we know nothing, then whatever provides AI is actually really not useful. But when we know something, when our base is strong, then we can utilize AI to build on top of that base. So this is my reflection, and yeah, thank you.